Today's lesson is on solving inequalities using addition and subtraction. So let's go ahead and start with a couple of key ideas here. We have the addition property of inequality and the subtraction property of inequality. These are very similar to the addition and subtraction properties of equality that we talked about in equations, but now we're talking about inequalities. So when you add the same number to each side of an inequality, the inequality remains true. Same thing for subtraction. When you subtract the same number from each side of an inequality, that inequality will remain true. Let's look at some examples. Here we have this inequality, x minus 5 is less than negative 3. To solve this, we want to get x by itself, just like we did for equations, but now instead of saying what x is equal to, we'll either say what x is less than, or what x is greater than, or maybe less than or equal to, or greater than equal to. So to get x by itself, we have x minus 5, so we need to add 5 to both sides. So our new inequality will be x is less than negative 3 plus 5 would be positive 2. So now when we graph this, we just want to be sure that 2 is somewhere on this number line. So I'm going to put 2 in the middle this time. And I'm going to fill out the other numbers. And we'll just count by ones. There's no reason to break it up smaller than that. And we know that x is less than 2. So 2 itself is not a solution, open circle. But anything less than 2 is a solution. And then I like to do a check on these to make sure that I've shaded in the right direction. So I'm going to look at a number that's shaded. 0 is a nice easy one. If 0 is shaded, that's a nice one to look at. And I'm going to plug 0 back into my inequality and make sure that I have a true statement. So let me use a different color here. I'm going to say 0 minus 5 is less than negative 3. 0 minus 5 is negative 5. And that is less than negative 3. So we have shaded correctly. We've shaded the right solution set. Let's look at another example. Here we have 13 is less than or equal to x plus 14. We can subtract the same number from both sides of the inequality. In this case, we want to subtract 14. And on the right side, I have x. On the left side, I have negative 1. And then I have this less than or equal to symbol. So this reads negative 1 is less than or equal to x. Now, for some people, it's helpful to kind of reverse this inequality while graphing and think this means x is greater than or equal to negative 1. So if that helps you, feel free to think of it that way. I think I'll put 0 in the middle this time. And we have negative 1, negative 2, 1, and 2. And let's see, we know that negative 1 is important here, and negative 1 is a solution. So we're going to fill it in. And we know that x is greater than or equal to negative 1, so that means we're going to shade this direction. Sometimes we look at this and see the less than symbol and think we're shading this direction, but because we have x on the right side of the inequality, that means in this case we're actually shading to the right. But we do want to check on this, especially when we have the variable on the right side of the inequality. So let's use 0 to check, since 0 appears to be a solution. We'll say 13 is less than or equal to 0 plus 14. 13 is less than or equal to 14, so yeah, that's true. So we can use any value that's part of the solution set to check. I wouldn't recommend using negative 1 to check, though, because that won't tell us whether we shaded the right direction. Okay? Let's look at one last example where we have this real-life application. So we see that a person can be no taller than 6.25 feet to become an astronaut for NASA. They must not want you to be too tall in those spaceships. Your friend is 5 feet 9 inches tall. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. Okay, so first we kind of have to deal with our units here because our requirement is written in feet, but then we have a height of our friend that includes inches as well. So let's convert this 5 feet 9 inches to just how many feet that is. So 5 feet 9 inches we know that there's 12 inches in a foot, so 5 feet would be 60 inches. So 60 plus 9 would be 69 inches. And then if we want to convert that to feet, we can say 69 inches times, there's 12 inches in 1 foot. So if we multiply by this ratio, what we're really doing is dividing 69 divided by 12, which is 5.75 feet. Which if we think through it, that makes sense. 9 inches would be 3/4 of a foot, so 5.75 feet seems about right. Now, let's go ahead and write our inequality here. So here's how tall our friend is right now. And then he or she can grow a certain amount. So let's use H for how much they can grow. And however much this is, it needs to be less than or equal to 6.25. So if our friend doesn't grow at all, that should be okay. But they can grow up to a certain amount, and then at some point they become too tall to be part of NASA. So to solve this inequality, we can subtract 5.75 from both sides. And we get this H, the amount that our friend can grow, is less than or equal to 0.5 feet. So how much our friend can grow and still meet? It can grow 0.5 feet, or that's also H is less than or equal to 6 inches. All right, so go ahead and try a few on your own. Be sure that you are graphing all of your solutions. Put in a number to check your solution as well. I will see you soon.